Alright, hello, this is Mr. Crozier. I'm going to give you a walkthrough on this review sheet for Chapter 6. Problem number 1, find the angle between the lines. Well, for this formula we need the slope of each line, and the slope here would be, if I move this over to this side, I would have negative 3x plus 4 divided by 2. The slope is negative 3/2, and the slope of this line, if I move this over here, I'd have negative 4x divided by negative, so the slope here is just 4. Once you have the slopes, it's just a matter of filling out this formula where on the top I subtract the slopes. So I'm going to start with this one here, 4 minus 3/2 negative. And on the bottom, we start with 1 and we add, but we multiply the two slopes, so that would be a negative 12 over 2, which would be a negative 6. So that's the formula. On the top, subtract them. On the bottom, add them, but multiply them together here. If you do the calculations right, this will simplify down to 11/2 over 5 after you take the absolute value. And one more step, you could multiply by 2, and you would have 11/10. Now the answer calls for the exact answer. So the exact answer is theta equals the inverse tangent of 11/10. That's an exact answer, inverse tangent of 11/10. Now if you have a calculator, let's see here, put it in radians. I could do inverse tangent of 11/10, and there's my answer in radians, 0.8330. And I could switch it to degrees, and inverse tangent of 11/10, and there's my degrees. So all three answers, that's the angle of inclination, that's an exact answer. Number 2, identify the conic. Well, it's being subtracted, so it's definitely a hyperbola. It's definitely a graph with two different parts like this. All right, have to complete the square. Well, let's do the x's. 9x squared, factor out at 9, 2x plus something, minus 16y squared, and be careful right here, it needs to be plus 2y. It needs to be plus 2y because a negative times a positive makes a negative right there. All right, and put this over there, 151. What do I need here? Well, I take this, divide it by 2, and it's 1, square it, and it's a positive 1. And I added on 9 to that side, squared. What do I do here? Take this, cut it in half, it's 1, square it, it's 1. I added on 16, but it's a negative 16. That math comes out to be 144. Divide that over, you have x minus 1 squared over 16 minus y plus 1 squared over 9 equals 1. That's your standard form. That's the conic, and the center would be 1, negative 1 for a center. All right, going on to number 3. We have a lot going on here. And what you need to know is that we're talking about angle inclination with points. So I'm going to start right here and say the tangent of theta is equal to m, because that's how that angle of inclination is found. It's the tangent is the slope. Well, my slope is given to me in terms of points. So that's my point or my slope formula. And now that I have that, I can fill in all my pieces. Tangent of 149 degrees is equal to 10 minus a, negative 2 minus 3. Get a calculator out. Again, now I'm in degrees, so I'm in degrees here, and the tangent of 149.04 is 0.5999. We are rounding, so it's going to be safe to round this to negative 0.6. And this is 10 minus a, on the bottom negative 5. Multiply this over, I think that's 3. And let's see here, add this over to this side, subtract this there, a is 7. The distance formula, well, the distance equals absolute value. Let me move this around, and I have x plus y minus 5 equals 0. Hopefully you know the distance formula by now. If not, look this up. It is 1 times 7 plus 1 times 5 minus the 5, all absolute value, over square root of 1 squared plus 1 squared. Distance equals, the numerator comes out to 7, divided by root 2, times it by root 2. 7 root 2 over 2 is an exact distance. Punch it in your calculator. I think you'll find it's 4.9. All right, down here, graph these on the polar grid. Well, they give you the radius first, and then they give you theta. So, and when you see this, probably the first thing you want to do is divide this up. This is 0, and this is pi, and this is pi over 2, and this is 3 pi over 2, just like back to the unit circle days. And then the question is, well, what are all of these? Well, this is 90 degrees, so 1, 2, 3, 4, 5, 6. 90 divided by 6 sections happens to be 15. And look how nice they did this for you. This is 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees. So it looks like a lot of random marks here, but they're cut in a way so it helps you with the unit circle. So where's this first point? Radius 4, so I go out to ring 4, 1, 2, 3, 4, and I turn to pi over 6. Well, that's right there, A. Well, where's this one? Well, -3 ring, but I turn to this angle with 3/4 pi. Well, there's 1/4, 2/4, 3/4 is right there. That's what that line is for. This is pi over 4. 1/4, 2/4, 3/4. And so I'm going this way, but wait a minute, it's negative, so I go backwards. So I'm really going back this way. 1, 2, 3. Point B is down here. C, 2 ring and 2 radians. Well, every radian is 57.3 degrees. So about 114. So where's 114? Well, if this is 120, this is 90, this is 105, 114 is somewhere in here. It falls about right there. So these are on exact lines. This is an estimation. All right, how do I do this one? 31 divided by 6 is 5 and 1/6 pi. So I have 5 pi and an extra 6. Well, that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and an extra 6 would be right there. And we're out to 2. Label your unit circle when you see those. On the back, a moon travels around a planet. So here's the path of the moon. It's in an elliptical orbit. 2 distances here. There's the moon. And it's going around a planet. However, the planet's not at the center. So that's not the planet. The planet's right here. The planet is over here somewhere. And gives us some measurements. How far is the planet from the center? So we're looking for this distance right here, which hopefully we know by now is the foci. And this is A, this is B, and this is C. All right, so what's A? Well, the major axis is 410,000 divided by 2. That's 205,000. And what is this one? Whoops. Divided by 2. That's 175. So my formula for this focal distance is a squared minus b squared equals c squared. That's a squared because it's the longest, minus b squared equals c squared. Okay, that's the calculator problem. Squared minus squared. That's the large answer, but I'm taking the square root. So it's the square root of that number, and that's that C distance. C is about 106,771 miles. So this distance in here is 106. The whole thing is 205. So the planet distance is 106. Makes sense. All right, given the parabola, find the directrix and focus. Well, Can't do much with this in this form, so let's go ahead and put it into standard form. Factor out a 2. Alright, now I can graph my parabola. Ready? Parabola is, center is at 1, 0. Hey, there's the center. It is a y squared parabola, so it's left to right. This is positive, so it's right. There's my parabola. There's 1. There's 2. 1, 2, 0. And we have two things we need to identify. First is the focus. Well, that's over here. And the directrix is over here, but how far do they move? Well, we call that movement the letter P in the book. The P value is equal to A divided by 4. So P is equal to 2 divided by 4, which is 1/2, which means this focus is moved over 1/2 point 2 right there. So the coordinates of the focus, and it's a point, so it's 1.5, 0. Now the directrix is this line right here that's again moved over 1/2. And the directrix is a line, which is x equals 1/2, because that's where it is. So this movement here is a 1/2 this way and a 1/2 that way. 1/2, 1/2, that's how you find the 1/2. A value divided by 4. You can put absolute value. Just know that the focus is inside, the directrix is outside. Table for our parametric equations. Well, the input is 0 to 5, delta 1, so that would be t would be 0, 1, 2, 3, 4, 5. And the x term and the y term, well, the x term's easy, I just square it. Kind of looks just like our parabola table. On the y term, we have to do 4 sine, and make sure you're in radians here. This is a trig problem, and there's no mention of degrees in here, so we're going to assume it's radians. Alright, I'm in radians, and now what I'm going to do is 4 sine 0. 0. New one, 4 sine 1. 3.4. Try it again, and plugging in, we're going back to the t. Remember, the t is the input. You have to ignore this column right here. You go back to the t, and this is 3.6, and 4 sine 3, 0.5 or 0.6, 4 sine 4, negative 3, and 4 sine 5, negative 3.8. All right, I have to graph this. Well, when I graph it now, I'm just looking at the x and y's, and for my y's, all I see is I'm going, or my x input, I'm going up to 25, so 5, 10, 15, 20, 25. For my y's, I'm trying to get close to 4, because of that amplitude right there. 1, 2, 3, 4, 1, 2, 3, 4, 5, 10, 15, 20, 25, 4, negative 4. I can plot my point. 0 is, when I plot them, I'm not looking, I'm going to get rid of these t values and just plot the x and the y. 1 is 3.4, about right there. 4 is about 3.6. 9 is 0.6. 16 is negative 3. And 25 is negative 3.8. Way down here. All right. So I graph it, and it looks kind of like a roller coaster, right? It goes up for a while, then it goes down, then it curves down this way. However, this is a parametric graph, so don't forget to put directions. Between each point, show the direction. That's where it's going. And the direction is it's following t. 0, 1, 2, 3, 4, on, and on. Let me see if I can't graph it on here for you. If you hit window, I'm going to go from 0 to 25, and negative 4 to 4, and 5, and I'm going to see if I can graph it in parametric. I haven't done this yet, so we'll see if it works here. T squared, and here is 4 sine t, and did not work out right on my table set, so I'm not going to worry about graphing it on here yet, but you can see it goes up, comes down, goes that way. All right, problem number 9. Here we go. Graph the ellipse. Here it is. Why don't you graph it? Well, we can start here at 2, -1, 2, -1. I've already done it, so I do know it comes out well at these ones. -5. And on the y-axis, it's 16, so that's 4. 1, 2, 3, 4. And 1, 2, 3, -4. On the x-axis, it's 2. So there's a good sketch of what my ellipse looks like. But however, now we have to do more work here. And it says find the exact values of the foci. And I have to graph the foci too. I haven't graphed the foci. I've got the center vertices, co-vertices, but not the foci. Well, thankfully we know the formula. A squared minus B squared equals C squared. A squared, A's 4, A squared is 16, minus 4 is C squared. C squared is root 12. I'm going to go ahead and simplify that whenever I can. That's 2 roots of 3. All right, so what is the, where are the foci? Well, the foci are out to 2 and -1. However, I'm going to go up 2 roots of 3. So I'm going to start here and I'm going to go up. And here, I'm going to start at -1, but I'm going to go down. So these are the exact answers right there. Now, where are they if I plotted them? Well, -1 plus 2 roots of 3 is about 2.4. So here's 0, 1, 2.4. So it's in between this last section. And -1 minus 2 roots of 3 is -4. 1, 2, 3, 4. That's where the foci are. All right, and the last thing is the eccentricity of it. Well, that's just taking C over A. It's a measurement of how close the foci are to the vertices, and this is really close. It's almost there, so it's almost 100%. And I would just take this C value, which is 2 roots of 3, and divide it by the A value, which is 4, which is exactly root 3 over 2. And if you want to get a decimal for it, the square root of 3 divided by, the square root of 3 divided by 2 is 0.87. I always think of it like a percentage. How close is this to this? Well, it's 87% of the way there, kind of. Not exactly, but it's a good reference point for your understanding. And if it was all the way down here, it'd be close to 0%. So it's like 0, 10, 20, 30, 40, 50, 60, 70, 80%. Now the numbers don't scale that way perfectly, but this is a good way to remember it. C over A, how close is this to there? 87%. All right, hope this helps with your work. If you have any questions, let me know in class, but study this for your test.